TLC Math Made Easy. This video is all about theorems on trapezoids. What is a trapezoid? A trapezoid is a quadrilateral with exactly one pair of parallel sides. So in the given quadrilateral ABCD, AB is parallel to CD. Or we can write that as AB is parallel to CD. So these are the only sides, or this is the pair of sides that are parallel. The parallel sides are called the bases of the trapezoid. So in the given, AD and BC are the parallel sides. So therefore, AD and BC, AD and BC are the bases of the trapezoid, while the non-parallel sides are called the legs of the trapezoid. So therefore, AB and BC are the legs of the trapezoid. In the trapezoid ABCD, E and F are the midpoints of the legs AB and DC respectively. And the segment joining the midpoints E and F, which is EF, is what we call the median of the trapezoid. So the median is the segment joining the midpoints of the legs of a trapezoid. The median is also parallel to its bases. So we can say that AD is parallel to EF and parallel to BC. Let's take a look at the trapezoid DEFG. What is the length of the base DE? So if we look at the grid, then we can say that base DE is 3 units and that base GF is 8 units. Now we can also see that HI is 5. 5.5 units. Let's take a look at the trapezoid ABCD. What is the length of the base AB? So by looking at the grid, we can see that AB is equal to 3 units. DC or CD is equal to how many units? 1, 2, 3, 4, 5, 6, 7. So there are 7 units. And for the median EF, we can see that EF is 1, 2, 3, 4, 5 units. So the grid has made obvious the fact that the length of the median of any trapezoid is half the sum of the lengths of the bases. That is, EF is equal to 1/2 the sum of AB, which is 3, and CD, which is 7. So that is 1/2. 3 plus 7 is 10, and 1/2 of 10 is 5 units, which is the same as this. So we can say that the median of a trapezoid is half the sum of the lengths of its bases, or that is EF is equal to 1/2 the sum of AB and CD. Some examples. Trapezoid JKLM is is a trapezoid with median NO. If JM is 43 and KL is 57, find NO. So we have the measures of the bases. JM is 43 units and KL is 57 units. So NO is the median. So using the formula, we can say that NO is equal to 1/2 the sum of JM and KL. So substituting the values, NO is equal to 1/2, JM is 43 plus 57. So NO is equal to 1/2, 43 plus 57 is 100. So 1/2 of 100 or 100 divided by 2 is 50. So therefore, NO is 50 units. Next, if JKLM is a trapezoid with median NO and JM is 3x plus 10, KL is 2x plus 50 and NO is 20, find x, JM, and KL. So JM and KL are the bases and NO is the median. So using the formula, NO is equal to 1/2 JM plus KL. So we substitute the values. NO is 20 units equals 1/2, or we can write it as 3x plus 10 minus 10 plus KL, that is 2x plus 15 divided by 2. And by the multiplication property of equality, we multiply the whole equation by 2. So we get 2 times 20 is 40 equals 3x minus 10 plus 2x plus 15. So 40 equals, combining similar terms, 3x plus 2x is 5x. Negative 10 plus 15 is positive 5. So by the APE, 40 minus 5 equals 5x. And 40 minus 5 is 35 equals 5x. So to solve for x, we divide both sides by 5. So therefore, x is equal to 35 divided by 5 is 7. So x is 7 units. And JM, that is 3x minus 10. So we just substitute the derived value of x, that is 7. So 3 times 7 minus 10, that is 21 minus 10, that is 11. So JM is 11, while KL is 2x plus 15. Again, we substitute the value of x, which is 7. 2 times 7 plus 15. 2 times 7 is 14 plus 15. So therefore, KL is equal to 14 plus 15 is 29. How about this one? NO is 23. JM is 18. Find KL. So the given is the measure of one base, that is 18, and the measure of the median, which is 23. Again, we make use of the formula. NO equals 1/2 JM plus KL. So NO is 23, that is 1/2 of JM plus KL. So we multiply the whole equation by 2. So 2 times 23 is 46 equals. So cancel out 2 and 1/2. What's left is 18 plus KL. Now by the addition property of equality, we get 46 minus 18 equals KL. And 46 minus 18 is 28. So therefore, KL is equal to 28. How about this one? NO is given as 6x minus 10. KL is 7x plus 8 and JM is 3x plus 2. Again, the formula NO is equal to 1/2 JM, the bases JM and KL. NO is given as 6x minus 10, that is 1/2. JM is 3x plus 2 and KL is 7x plus 8. So we get 6x minus 10 equals, combining similar terms here, 3x and 7x is 10x, 2 plus 8 is 10, so divided by 2. So we multiply the whole equation by 2. So 2 times 6x, that is 12x. 2 times negative 10 is negative 20, so we can cancel out 2 and 2 here. What's left is 10x plus 10. By the APE, we get 12x minus 10x equals 10. Negative 20 becomes plus 20. 12x minus 10x is 2x equals 10 plus 20 is 30. So to solve for x, divided by 2, so x is equal to 30 divided by 2 is 15. So if x is, then x is equal to 15. There is a special kind of trapezoid, which is the isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. Remember that a trapezoid, not all trapezoids have congruent legs. Only isosceles trapezoid is a trapezoid with congruent legs. So in the given, the isosceles trapezoid ABCD, the legs are AD and BC. So we can say that AD is congruent to BC. Now there are theorems that are related to isosceles trapezoid. Let's have these theorems one by one. Number 1, the base angles of an isosceles trapezoid are congruent. So we can say that angle B or angle A is congruent to angle B, and angle D is congruent to angle C. Now, so therefore, let's say angle A is 93 degrees, then angle B is also 93 degrees. Since this is 93 and A and D are supplementary, then 180 minus 93 is 87 degrees. So angle D is 87 degrees and angle C is also 87 degrees. Is this clear? Number 2, opposite angles of an isosceles trapezoid are supplementary. As my example in the first theorem, angle A is 93 degrees, angle B is 93 degrees, and angle D is 87 degrees, angle C is 87 degrees. So opposite angles, angles A and angle C. So we can say that a measure of angle A plus measure of angle C is 180 degrees. So 93 plus 87 is 180 degrees. In the same way, measure of angle D plus measure of angle B is also 180 degrees. The last one, diagonals of an isosceles trapezoid are congruent. Take note that the diagonals of a trapezoid are not all congruent. Only the diagonals of an isosceles trapezoid which are congruent. So we can say that the diagonal AC is congruent to the diagonal BD. So if BD is, let's say, 7, if BD is 7 units, then AC is also 7 units. Now let's apply the theorems in solving some quantities involving isosceles trapezoid. In an isosceles trapezoid ABCD, measure of angle D is 3x plus 50. So this is 3x plus 50 degrees. Measure of angle C is x plus 64 degrees. We know that angle D and angle C are base angles. So by Theorem 1, base angles of an isosceles trapezoid are congruent. So we can say that measure of angle D is equal to the measure of angle C. Measure of angle D is 3x plus 50 and measure of angle C is x plus 64. So by the addition property of equality, 3x, or combining similar terms, 3x minus x, 64 minus 50. So 3x minus x is 2x, 64 minus 50 is 14. So dividing both sides by 2, we get x is equal to 7. Since measure of angle D is equal to 3x plus 50, so measure of angle D is equal to, by substitution, 3 times 7 plus 50. 3 times 7 is 21 plus 50 is 71 degrees. So we can say that angle D is 71 degrees, and since angle D and angle C are congruent, then angle C is also 71 degrees. By the second theorem states that opposite angles of an isosceles trapezoid are supplementary. Since angle A and angle C are opposite angles, then therefore they are supplementary. So we can say that measure of angle A is equal to 180 degrees minus 71 degrees. So 180 minus 71 is 109 degrees. So angle A, measure of angle A is 109 degrees and measure of angle B is 109 degrees since angle A and angle B are congruent. Number 2. In an isosceles trapezoid ABCD, again, the given is still the same. But measure of angle A, or let's say measure of this one is, or DAB, it should be DAB, that is 5x minus 21. And measure of angle C, or BCD, that is x plus 57 degrees. By Theorem 2, it states that opposite angles of an isosceles trapezoid are supplementary. So we can say that measure of angle A plus measure of angle C is equal to 180 degrees. Measure of angle A, that is 5x minus 21, plus measure of angle C is x plus 57 degrees. Equate that to 180 degrees. So, combining similar terms, 5x plus x is 6x, negative 21 plus 57 is 36, equals 180 degrees. So, by transposition, 6x equals 180 degrees minus 36 degrees. 6x is equal to 180 minus 36 is what? 144 degrees. So dividing both sides by 6, so we get x. 144 is equal, divided by 6 is equal to 24. So x is equal to 24. Now, the measure of angle A is, or I think it's easier to use measure of angle C. Measure of angle C is x plus 57 degrees. Since x is 24 degrees plus 57 degrees, that is equal to 81 degrees. So measure of angle C is 81 degrees. Since angle A and angle C are supplementary, then measure of angle A is equal to 180 degrees minus 81 degrees. So 180 minus 81 is 99 degrees. So, angle A is 99 degrees. Since angle A and angle B are congruent angles, base angles, so angle B is also 99 degrees. Since angle D and angle C are congruent, then angle D is also 81 degrees. Is this clear? I think this is the last one. BD and AC are the diagonals of the isosceles trapezoid ABCD. And by the last theorem states that diagonals of isosceles trapezoid are congruent. So therefore, BD is congruent to AC. So BD is equal to AC. We get the value of BD, that is 9 times x minus 3 equals AC is 8x plus 1. So by the distributive property of multiplication over addition, 9 times x is 9x, 9 times negative 3 is negative 27 equals 8x plus 1. So by transposition, 9x minus 8x equals 1 plus 27. 9x minus 8x is x equals 1 plus 27 is 28. So x is equal to 28. Now if x is equal to 28, find AC. So AC is equal to 8x plus 1. AC is equal to 8 times the value of x, which is 28, plus 1. What is 8 times 28? Alright, 8 times 28 is 224 plus 1, so that is 225. Therefore, AC is equal to 225. And since AC is equal to 225, then BD must also be equal to 225. I hope that you learned from today's video. And don't forget to like and subscribe our channel, TLC Math Made Easy. Thank you for watching. God bless everyone.